Hello everyone. Today I'm going to solve some questions on chapter 1 of differential equations textbook named Dennis Giesel, Advanced Engineering and Mathematics. I would recommend the 8th edition of the book. That's the one I'm currently looking at, and I'm going to solve questions on chapter 1 covering all of the main topics. So yeah, let's get started. Okay, so for this question, we just need to determine if the differential equation is linear or not, and as well as the order of the equation. So for the first one, I'm going to use the notation of y prime prime, by the way. So it goes y prime prime plus sine of t plus y equals sine t. You guys can pause and try to solve these for yourself first, and I'm just going to show the solutions. So the first one here is going to be a second order because of the y double prime here, and it's going to be nonlinear because we have our dependent variable y inside of a sine function, which is nonlinear. So this equation is going to be second order and nonlinear. The second one, t squared y prime prime plus ty plus 2y equals sine t. This one is going to be second order as well because the y double prime. And it is going to be linear. The reason it's linear is because we do not have the dependent variable in front of its derivative, so we have the independent variable in front of the derivative of the dependent variable in this equation, which is fine, and we don't have any nonlinear functions as well as no power that are greater than 1 for the dependent variable, so this is going to be linear. The third one, y prime plus ty squared equals 0. This is going to be a first order, and it is going to be linear. Sorry for my handwriting. Oops. Linear. Getting used to this little pen tablet, guys. I'm sorry. And for the fourth one, I'm just going to do it right here. Over here, we could see that we just have the derivative of y, the second derivative, the third one, and the fourth one, no coefficients and nothing special, so this is just going to be a fourth order because we have the fourth differentiation of y, and it is going to be linear. That's it for this question. Okay, let's start problem 2. So question 2, the solution of a certain differential equation is of the form y of t. I'm going to rewrite it as y of t equals a e to the power of 7t plus b e to the power of 12t. So we know that this is the solution of some differential equation, and we are given some boundaries here, some initial conditions. This is known as an IVP, initial value problem. So we're given y of 0 equals 2 and y prime of 0 equals 1. It's very important that we're given the same boundaries here. If not, it would be a boundary value problem, BVP, but we're given the same input for the function. So y of 0 and y prime of 0. Now, we know that the solution of the differential equation is given like this. Sometimes it's also they use C1 and C2. I was given A and B, so it's pretty much the same thing. And we know that for our specific solution, we're looking for, this is the general solution, but we're looking for a particular solution. And our particular solution passes through these points. So we know y of t, and we're just gonna plug y of 0 in here. So y of 0 would actually just give us a of e. 7t would just vanish because 7 times 0, so you just get 0, and same thing for b, e to 0, so, and this would equal to 2. So we know a plus b equals 2. Now for y prime, we would need to take the derivative of yt. So y prime of t is 7a e to the 7t plus 12b e to the 12t. And now we just do the same thing, except now we know that y prime of 0 equals 1, which is equal to 7a e to the 0 again, plus 12b e to 0. And the 1 is, just solve the equation, 7a plus 12b. Gotta scroll down. Okay, so I'm just going to, using the first equation, we know that a plus b equals 2. I'm going to say that a is equal to 2 minus b. So now we just go 1 equals to 7, 2 minus b, right? Because we have, you get 2 equations with 2 variables. You just want to solve. So this plus 12b, this is going to give 1 is equal to 14 minus 7b plus 12. Simplify. Plus 5b, if I'm not mistaken. Yeah. And now bring this to the other side. You get negative 13 equals to 5b, and so b is equal to negative 13 over 5. All right, we have a value for b, and now we could just plug it in to the equation over here. So a plus b equals 2. We could just say a minus 13 over 5 equals 2. And if you solve this, you'll find that a is equal to, what was it, 23 over 5. This is the right answer. I'm just trying to show you guys how you get to the answer. But if you calculate this, you'll get 23 over 5. Therefore, you now just plug it back into the formula to get your particular solution. You will see that you have 23 over 5 e to the 7t plus or minus 13 over 5 e to the 12t. That's it for question 2. Let's go to question 3 now. Okay, so question 3 is pretty easy. It's very similar to question 1, except we have to determine the independent and dependent variable. Using the little trick I gave earlier, we could just write, for the first one here, we could just write dy over dx instead of y prime equals y minus x squared. And you know that this is your dependent variable on the top, so that's why we have y, and then therefore the independent variable is at the bottom, which is x. We also know that the order of this differential equation is 1 because we have y prime as in just first derivative of the dependent variable, so this is going to be first order. And the function is linear. If you just bring everything on one side, you'll get y prime minus y plus x squared equals 0. And because we don't have anything with a power greater or less than 1, we don't have the dependent variable as a coefficient of any of the terms, and we don't have any nonlinear function, so this is going to be linear. The second one is xy prime. I'm just going to rewrite it, minus 2y equals 0. We have x as the coefficient here, so it's fine, and we don't have anything greater than 1 for the powers, no nonlinear functions. So again, this is going to be linear. You could use the same as before, the trick, to know that this is going to be the dependent variable, and this is the independent variable, and again, it's just y prime, so it's first order. And now for the last one, we have x prime prime. This is actually a special case, like this one, minus e to the negative x. I just like putting everything on one side because it's more visual, it's easier for me. X prime prime plus 5x minus negative x. What do we notice here is that we actually don't have the dependent variable or the independent variable. In this case, we're going to assume because x is prime prime, we know that it's going to be d squared x over d something. We don't know what the independent variable or the dependent, oh my god, yes, the independent variable is. Sorry, I got confused. And it says that use t for the independent variable if an independent variable is not given explicitly. So we're going to use t, and assume that it's like that. So plus 5x minus e to negative x. Now, if x is our dependent variable and t is our independent variable, now we could start looking at the coefficient. We don't have a coefficient for x prime prime, so this factor's fine. 5x is good. Now negative e to negative x. This right here is our dependent variable, and it's to the power. Because of this, it is nonlinear because e is considered an exponential function, and so it's not linear. And yeah, that counts, and that makes the entire equation non-linear. Or just written here, 2x and t. Yeah, the order is second order because of this. So yeah, pretty easy question. Let's move on to question 4.